Welcome back, everyone. In this lecture, we're going to talk more about experimental designs and their connection with internal validity. You may recall that internal validity is all about causation. How certain can we be that one causal variable causes or influences some outcome variable, some dependent variable? And so one of the key things we have to think about with experimental designs is various threats to internal validity. So as you can see here, we've got 6 different main categories of threats to internal validity in experimental designs. So when you think about an experimental design, you're thinking, I want to be certain at the end of my study that I've either established or failed to establish that my independent variable is having a significant causal influence on my dependent variable. So you almost think you want a good experimental design should almost be thought of as being conducted in a vacuum, where you want to control everything. You want to make sure that the only thing, once I walk out of this vacuum, once I walk out of this research setting, I want to be certain from my results, if I see a change in the dependent variable from, say, the pre-test to the post-test, I want to be certain it was only due to the influence of that independent variable. So you can imagine there's a lot of ways that it can be contaminated. So this like sterile vacuum type environment of an experiment, we want to keep it as sterile as possible. All the threats, for the most part, come from some form of contamination. So we're going to walk through each one of these 6 categories throughout this lecture. And then we're also going to wrap up very briefly with showing how experimental designs connect to some other types of validity that you can read more about in your course textbook. So the readings that are going to go along with this are going to be chapter 7 in your course textbook, and then also an article that I posted on Beachboard, and I just labeled it True Experiments in CJ Research, and it's in the content handouts area. Even though the article itself is, I think, pushing 20 years old, it still is one of the best examples of the importance of experimental research. So as you read through it, read it almost like you're reading a newspaper or magazine article. The first section of it kind of goes through and talks about the importance of experimental research in our field of criminology and criminal justice, especially when we're trying to design effective policies, programs, law enforcement tactics, intervention strategies for offenders, things of that nature. And then it goes specifically into 2 separate studies where researchers try to design as close as possible to that randomized true experiment. One took place in Broward County, Florida. And as you read about that one, the one thing I want you to think about is note how influence from the prosecutor's office led to these outside events that we're going to be labeling in a few slides as time-related threats, specifically the history threat, could have had a significant impact on the validity of the findings of that study. A second one takes place up in Oregon, and here they talk about a few things. The main focus of contamination to that study is something that we're going to look at when we get to the contamination in the experimental or treatment group, where some of the law enforcement officers and people in control limited the various victim empowerment strategies they talked about. And you can sort of see how these threats sort of leach into this study and can obviously have an impact on the accuracy or validity of the findings. That Oregon experiment, they also talk about issues with trying to deal with one of the key sort of preventive measures against threats to internal validity, which is having a double-blind study, and we'll define that too. So I encourage you to take a look at chapter 7 as well as that article that I posted on Beachboard, and let's go ahead and get started. All right, the first 2 of the 6 threats to internal validity we're not going to spend a lot of time on. We've kind of talked a little bit about these in other instances throughout this course. The first is reverse causation. And you saw this, I think, in our last slide when I introduced experimental studies. And that's the idea that sometimes we think, does A cause B, or is it possible it's the reverse, that B causes A? And I think the example that I used in a previous lecture was talking about drug use impacting academic performance. Well, if I'm doing a study to see does drug use have an influence on academic performance, I have to make sure I have controls or way to prevent getting a misleading finding where it could have been possible that academic performance led to drug use. So these are a threat to correlational designs, those survey-based research that we've talked about previously. But experimental designs, because a key component of experiments is the fact that the researchers are able to manipulate or control who gets the independent variable, who doesn't, or who gets what varying degree of the independent variable, we can make sure that it temporarily precedes the dependent variable. So reverse causation is usually not a big problem in experimental research. So that's a good thing. The second one is known as mortality. Mortality, another word that we've talked about before when we talk about longitudinal studies, was the term attrition. Mortality and attrition go hand in hand. Even though mortality sounds rather morbid, it refers to the broader sense of losing research subjects for any reason, right? So obviously, yes, if you're conducting a study that takes place over time and some of your research subjects happen to pass away, that's mortality in a literal sense, and you lose them from your study. But oftentimes or more often, you're going to have people who just decide to stop participating or want to walk away from it, or you can't find them again. That would still fall under this threat of mortality. Why is mortality a threat to internal validity? Well, there's usually something particular about the subjects that leave a research study, especially when we're examining individuals who are engaged in criminal behavior or drug use or a lot of the things we study in our field. There may be something particular about those individuals that the fact that we lose their data may lead some bias into our overall results. At the end of the day, though, there's no way to control for mortality. You can't ethically force people to participate, and if people, pass away, they pass away. You can't bring them back to life. So there's no way to control for it, but we just need to make sure that we keep track of it and report it as, one of the limitations or something that you would write up in any sort of research article. Now, the third category of threats, I'm going to broadly refer to as what are known as time threats. Your course textbook sort of throws a lot of these threats in various sections. In my previous training and other course textbooks that I've worked with, I like the way that they're categorized sort of into these 6 categories that we're starting with in this lecture. So I'm going to kind of keep it that way, but you'll see them sort of scattered about in the pages in your course textbook without any sort of headings as called a time threat, but they are. So what is a time threat in a general sense? Time threats are when changes that we see in the dependent variable, say the pre-test of the dependent variable to the post-test, are not due to the independent variable, but they're just due to anything that else outside of that study. Remember that vacuum, that bubble, that we would like an experiment to be perfectly sterile and clean. Anything that comes in and contaminates or is an influence from outside of that sort of bubble of the study that may influence the research subjects and change the measurements of their dependent variable. So there's 4 major types of time threats. The first one, even though the name once again may sound a little misleading, it's just the term that's used in research methods, and that is history. So history refers to anything that is going on outside of the experiment that may contaminate the findings. So when you read that one article that I posted on Beachboard, the Broward example, the prosecutor's office and their sort of disdain or lack of confidence in the research study that is being discussed, you'll see they throw up a lot of hurdles, and those are things that could potentially have an influence. They talk about how the morale of the researchers is impacted, how it potentially could influence how the subjects behave. So that is something that is a contaminant that is not the actual independent variable, the thing that we want to see influence our dependent variable. So anything that happens outside of the experiment could be considered history. A second type of time threat is maturation. So maturation by nature is sort of directly related to time. So if your study takes place over, even if it's over the course of a couple months, or maybe it takes a couple years, you think that humans are going to have physiological and psychological change over time. So if you're studying somebody's sort of levels of depression or somebody's levels of anger or somebody's level of knowledge, you can imagine that that would change naturally over time, irregardless of whatever sort of intervention or independent variable you may be introducing to them. So that can contaminate. So that typically is referred to as maturation. Another thing we have to think about is instrumentation and then reactivity and testing. So these last two types kind of go hand in hand together. This is where it's very important, and a term you're going to hear throughout here, a way to control for a lot of threats is sort of standardization, right? So instrumentation, it means if we change how we're measuring our dependent variable, if we change the survey to measure that dependent variable, or if we're using more of a biological or physiological measurement, if we change how we do it, or if we have different researchers collecting that data, we have to be careful because there may be sort of contamination introduced by simply how we measured our dependent variable. And remember, even though an experiment has that manipulation of the independent variable, we still measure the dependent variable. So oftentimes it's similar to what we do with survey research, right? You may ask people questions about their feelings or opinions, or you may observe their behavior. So how we measure that dependent variable is very important. And then obviously that reactivity and testing also talks about if we had a pre-test or a baseline measurement to assess the level of the dependent variable, it's possible that people may remember how they behaved prior, and that may influence their actual responses on the post-test outside of the influence of the independent variable. So how do we control for these time threats? Well, the best control overall, when in doubt, the best control for a time threat is to make sure you have a control group. And so, that's sort of the gold standard to sort of detect the influence of time threats. And you'll notice down here at the bottom where I say controls, presence of a control or comparison group, you'll notice I say it doesn't stop those threats from occurring, but it detects their presence. And why that is important? Well, because if these outside threats, history, maturation, etc., are influencing the people in the experimental group, if I have a control group who is not getting the manipulated independent variable, that control group should also have those same sort of time-related effects happening to them. And so that allows me to detect the presence of these changes in the dependent variable, and therefore I can sort of remove them from my analysis once I get all my post-test results done. Another way to control for it is you can always minimize the length of the time of the study. Obviously, you're less likely to see a lot of things happening outside of an experiment or much maturation if you can reduce the time period of your overall study. And then in order to fight against instrumentation and reactivity, standardization throughout the course of the experiment, whether that is trying your best to make sure you have the same researchers or research assistants collecting the data, you have the same measurement strategies, etc., in place. All of these can be ways to sort of reduce the effect of these time threats. Now, our next category, category 4, are referred to as group threats. So I've referred to group threats also in a previous lecture. So group threats are when the observed difference that we see in a between subjects or a mixed subjects research study, the observed difference between the groups, the control and experimental groups, is due to actual differences between the groups, but not due to the influence of the independent variable on the experimental group. So what happens? How do we end up with these group threat problems? Well, the first is what we call is selection biases. If we have people, if we sort of purposely decide who gets to be on which team, quote unquote, like the experimental team versus the control team, or if we allow them just to sort of choose which team they want to be on, which group they want to be in, that can lead to biases as far as a selection strategy, because Certain people may be more interested in being in the experimental group. Other people may want to just be like, oh, I just want to participate, but I don't want to do anything. So I was going to be in the control group, right? So you can imagine any sort of bias where we don't have sort of a random assignment can lead to problems, and where the groups are going to be different from the get-go. Another thing that we see, and your book actually gives a pretty good example of the second sort of group threat, which is statistical regression. So oftentimes in research, we are trying to help the people who have the most extreme levels of some sort of construct or some variable. Okay, so imagine this. So if I'm trying to figure out how to help people who have depression or who suffer from depression, you would think, well, I want to definitely target people who have the severest forms of depression, right? So they're extreme in that on that particular construct. Or as an example in your book refers to, sometimes you're looking at people and you're trying to get people to reduce their rate of offending or get them to desist from criminal behavior. And so you may think, oh, I'm going to target people for my study who are the most active offenders or who have the highest rates of offending. The problem with those is if we pick people to participate in a study on extremes, so people who are very active, have high levels of offending, or say very low levels or high levels of depression, when we sort of pick them to be part of our study and sort of do that initial baseline measurement and say, oh, okay, you're a high level offender, you've been offending a lot, so I'm going to incorporate you into the study. It's possible we just got them during sort of like a binge era. Like they've been, kind of a bad example, I don't know, maybe it's not, but they've been sort of just at a over the top, almost binging on, substance use or being overactive in their offending levels. And the reality is people tend to move in waves. So whether it's substance use, levels of depression, criminal behavior, even the most extreme criminals are not going to be going out and committing a lot of crimes every moment of their life, right? So if we target people on this, we may be targeting that sort of at the peak of a wave. And so they may naturally, throughout the course of their study, their depression levels may go down. Their level of offending may go down. Their level of substance abuse may go down. And then when we get to the post-test, we go, oh, wow, it must have been the influence of our intervention, whatever our independent variable was, right? Our substance abuse counseling, our therapy group, whatever it was. And we think that must have worked. No, we just happened to pick them when they're on a high at that peak of the wave, and they came back to normal. That's what this idea of statistical regression is about. And that can bring in this idea of a group threat. So we never want to sort of group people on extremes or think about making sure that we have the most extreme individuals. We want a variety of people in both the experimental group and the control group. You don't want, so you want that sort of balance. Well, how do we do that? The gold standard for preventing group threats is to have random assignment within your study. And as I mentioned in the previous lecture, random assignment has been statistically shown to be the best way to that the two groups, the experimental and the control group, are equivalent on as many factors as possible. And oftentimes there's things that we don't even consider. So this could be not just gender, race, age, etc., intelligence, whatever, but it also could be levels of offending, psychological characteristics. So by ensuring random assignment, that's what you want to do. But one of the things you may realize when you read the article that I posted is that random assignment, especially in real world settings and especially amongst criminal justice or vulnerable populations, is easier said than done. Because as soon as you say, oh, we're going to have random assignment, you're going to have various constituents or agencies that are going to come in and say, well, now you're making it unfair because this group's not getting access to the treatment or things of that nature. So trying to get random assignment done in the real world is a really tough thing. And if you can't do random assignment, there's also this notion of what they call matching. And matching is for every person in, say, the experimental group, they have somebody who, at least on paper, looks very similar to that individual in the control group. So if I'm comparing, if I've got inmates at two different prisons and I'm going to do a matched sort of study, Well, then at prison one, if I get a man who is 30 years old, white, male, as I said, has whatever level of intelligence and education, has a certain criminal background, then when I go to prison two, I'm going to look for a guy who's roughly the same age, similar background, et cetera, that matches my first subject on paper and put him in the control group. And that's sort of a statistical way to try to get the idea of random assignment. It's not as strong as random assignment, but it's, if you can't get random assignment because of certain ethical or political or agency issues, matching is a good backup. Another thing to do, and once again, this doesn't check everything, but it helps a little bit, is make sure your study is designed with some sort of pre-test or baseline measurement of the dependent variable, so you can check to see, do the groups, at least once again on paper, not the intangibles, but on paper, do they appear to be roughly similar? That helps to reduce sort of these group threats as we go along lines. And then, as I talked about with statistical regression and the idea of how you select people to participate in a study, don't group on extremes. So that's why if you're doing a study to try to reduce depression, you don't want just the most severely depressed individuals to sign up for your study. You want people all across the spectrum to see, does your independent variable really have an influence? So these last two, number 5 and number 6, the contamination in each of the particular groups within the study, they have some more subcategories, so they'll be a little bit longer to break down, but I think we can get through it. So the first one is, if you think about a standard experimental study, you've got two groups, right? So you can have a comparison. You have your experimental group and you have your control group. Experimental group, they get the intervention, they get the drug, they get the therapy, whatever it is that you're trying to test. The control group, in a perfect world, in that vacuum, in that sterile environment, the control group should get nothing that resembles that drug, that therapy, that intervention. So you can imagine there's two ways that the contamination can sort of leach into that little experimental bubble. So we'll talk with the first one, which is, how can we get contamination in the experimental group? That experimental group, if you think about it, go back to that vacuum idea in the sterile environment. That experimental group, if we want to see, does the independent variable have a significant impact on the dependent variable, we want that experimental group to get nothing more than the purest form of our independent variable. So if our independent variable is a drug, or some sort of substance that we want to give them and see how it influences it, we want them to get nothing other than the purest form of that substance. If our intervention of our independent variable is some sort of treatment program or therapy, we want them to get nothing more than the purest form of that particular thing. So one of the things you'll notice is, and once again, going back to the article that I talked about, that I posted, in the Oregon example, you'll see how the law enforcement agency changes the victim empowerment strategies that are given to the people in the experimental group. And by changing these victim empowerment strategies, they're contaminating what is supposed to be given to those individuals. So when we break down these forms of contamination, we typically think of them in two different main areas. The first are what are known as demand characteristics. And this is a much broader form of contamination. And you'll see I even capitalize the word any. So demand characteristics are any cues, hints, changes, whatever, that provide subjects with ideas about what the goals of the study are, and therefore may affect their behavior, right? If people are signed up for a study and they're in the experimental group, and we hint to them that we're trying to improve, say, their reading skills, well, now they're going, okay, I'm going to focus on my reading, right? Or if we're focusing on improving health and exercise, well, if they know they're in the study and they're tipped off to that, they may start eating better. They may start exercising more. That's contamination. That's not what they would be doing on a day-to-day basis. So we've got to find ways to not tip them off or not give them hints about what the goals of the study actually are. And then sort of a subcategory of demand characteristics is the idea of experimenter expectancy. And so experimenter expectancy is specifically the ways in which the researchers or the research staff may provide cues or tip off subjects that will influence their behavior. Or sometimes this can also be if researchers change the research protocol in order to get results that are consistent with their hypotheses. So the demand characteristics are when anytime the subjects within the study or the experimental group are given a hint or a cue about what we're really trying to get them to do, that goes above and beyond what the actual intervention or independent variable was. The experimenter expectancy is when the researchers or somebody, research staff or somebody involved in the study, tips off or gives cues or changes things in order to get the experimental group to look better or do better than to get the results that they want. That once again goes above and beyond what the individual sort of independent variable was designed to do. So let's take a little closer look at demand characteristics and experimenter expectancy. So demand characteristics, as I mentioned previously, the key thing here is look at that first bullet point. It's all about the subject's beliefs and perceptions. So if the research subject sees something, hears something, believes something about how they're supposed to behave or act, that is once again above and beyond what the actual the drug, the intervention, the independent variable itself. If it's above and beyond that, that's a demand characteristics. So these demand characteristics are typically things that provide hints about the study's purposes and the responses that are wanted. So in the classic sense, we say any cue present in the experimental condition but absent in the control condition that therefore may introduce demand characteristics. So I say the pill. What do I mean by that? Well, if you're participating in a study and you suffer from nasty migraines and you're hoping to find a way for your migraines to go away, well, if every time you come in to participate in the study, if they give you a little pill and a glass of water to drink it down with, that's a hint that, oh, you're supposed to feel better after you get that. Well, if you then 30 minutes later say, oh my goodness, my headache feels so much better, it must have been the pill. Are we certain that it was actually the pill, or was it that hint, that demand characteristic, that sort of that placebo effect that led to your change? And so one of the things is lots of times if we're feeling depressed or if we're feeling angry or whatever it may be, we want to get the desired outcome as a research subject, right? And so if we're tipped off to that, that may be a false positive as far as our outcomes. And so we don't want that. So in order for these demand characteristics to occur, first of all, the subject have to be curious. They have to want to know how they're supposed to react, right? If you've got a bunch of college students who are participating in an experiment simply so they can get extra credit for some course and really don't care about it, but just want the extra credit, they're not likely to be curious. But a lot of our research involve people who really want to be helped, right? One of the things we talk about when you look at the article I posted, a lot of it goes about ways to help domestic violence perpetrators in order to get them to reduce their level of domestic violence. And in the second study, it's all about empowerment of victims, right? So you can imagine people in these settings, especially the victims, they want help. They probably want the empowerment. So you've got to be careful. And if they want to be curious and they want to know how they should react, we've got to make sure that it's actually just our independent variable that's influencing them and not something above and beyond that. And then I say also, in order for demand characteristics to occur, once a guess has been made about the study's purpose, subjects must be motivated to follow or avoid the research hypothesis. All right. So there has to be a sense of sort of the impetus is on the subjects. They have to perceive it, want to follow it, and go with that. And then I say two examples down here. So, the idea of, and I already mentioned this before, but I'll say it one more time. If you really want to feel better, will simply somebody saying, here, this pill should make you feel better, drink it with a glass of water, will simply that presence of thinking that you're getting help make you feel better? I know I imagine for some of you, if you feel like you've been sick or under the weather and you have the flu or whatever it may be, and you go to your doctor or the urgent care, and I know I can say for myself, sometimes I feel better just walking out when they're like, oh yeah, you're not going to die, but here's a prescription for antibiotics or whatever it may be. And before you even taken their prescription, you're like, oh, I think I'm already feeling better, right? Your mind calms down. And that's the same thing with a lot of different experimental studies. Same idea when we think about sort of human behavior and performance. When you're at work, when do you perform your best? Is it when you're completely working your shift alone and there's no superiors or supervisors watching over you? Or do you work a little bit better, try a little bit harder when your boss is around, right? I've seen this when we have to do peer reviews of instructors at Cal State Long Beach. One of the things is if they know that, somebody like myself or another one of my colleagues is coming in to do a peer review or sort of a teaching review of them, you can imagine that they're probably on their A game on that day or trying to be on their A game. And on other days, they may sort of mail it in, right? So these are all sort of examples in the real world of how demand characteristics work. So how do we prevent demand characteristics? Okay. Just like I've done with the other one, the number one thing is I'm going to start with most of these, I'm going to start with what I call sort of the gold standard. So the gold standard for preventing demand characteristics are either to be able to provide some sort of placebo. So you want the people in the experimental group to really look and act and behave, at least within the research setting, just like the people in the control group. So if the people in the experimental group get a pill, then the people in the control group should get a pill. If the people in the experimental group know they're going into some sort of treatment session, then they should think and feel that the people in the control group are doing the same thing. What this does by using a placebo is it makes the subjects blind to their condition. So the term blind in experimental research is huge. You're going to see it multiple times throughout the rest of this lecture. By making them blind, whether it be the experimental group or the control group, it increases the likelihood that the research subjects are going to behave as quote unquote normal as they normally would, or as normal as possible. So the more that we can sort of make both the experimental and the control conditions look very equal, the more likely our subjects are going to be blind to their condition. And also, in a simplest sense, you just don't tell your research subjects whether or not they are in the experimental group or the control group. You just don't tell them. And then another thing is sometimes when you're doing sort of like more natural experiments or in natural settings that are more observation based as far as measuring your dependent variable, you, to the extent that ethics allow, you avoid letting the subjects know when they are actually being tested or evaluated, right? Once again, if I'm supposed to be, think about driving your car. If I'm driving through my neighborhood on a random day with nobody else on the road, I may or may not stop at every stop sign. I may go a little bit over the speed limit, things of that nature. But if all of a sudden I know there's a cop sitting at the corner with a radar gun or watching the stop sign or a cop's following me, I'd imagine, just like me, many of you would probably say like, yeah, I make sure I'm driving even better than I normally would, right? So there's a reason why cops, when they're doing, checking for speeders and people running red lights and things like that nature, you can see why they sort of hide a little bit, right? Because if you don't know you're being watched, you're going to be more natural. And that's kind of the same idea with this. A third sort of category of preventing demand characteristics is that you can distract your subjects with a false cover story. So you can pretty much say, hey, you're coming in to do research about this topic, but in reality, we're checking something else, right? So there's a lot of social psychological examples within the social science field. Some of them are things as simple as like you recruit, like, say college students and say, oh, come into the computer lab and we're going to be doing a study to test your typing skills after having, been given a little lesson or whatever. And in reality, you're not testing their typing skills. You may then have, during the course of their typing, their competition and they're competing against each other in this room, you may have what sounds like, somebody crying for help out in the hallway outside, and you're really testing, what's the likelihood of somebody actually going out and helping somebody as a good Samaritan, and they are, bystander interaction, things of that nature. So cover story is another good way to prevent these demand characteristics, because you're trying to not give them a cue about what the purpose of the study is. But once again, you got to think about the ethical nature of a cover story. And then finally, when in doubt, if it's impossible to have a placebo or make the subjects blind to which group they're in, or if it's unethical to, provide a cover story or not let them know when they're being tested, the backup plan is always what we call the faithful subject. You just say, please behave as honestly as you would in an everyday situation. Okay, so let's move on to the other side, the experiment. So experiment or expectancy. So if demand characteristics are all about from the subject's point of view, and are they tipped off or do they have hints or cues about how they're supposed to behave, the experiment or expectancy focuses much more on the researcher or the research staff. And it's all about their goals and their desires. Because you can imagine if I'm a researcher and I'm participating, I've designed a study, usually I probably want my people in the experimental group to succeed, right? If I've designed some drug that I think is going to make people feel better, then I want the people who take the drug to actually report that they feel better. If I've designed some sort of, educational program that's going to help people get better, do better in school, you can imagine the people, when I test the effectiveness of my program, those in an experimental group, I really want them to succeed. So researchers typically want the experimental subjects to succeed. And I say here under that second bullet point, the late bloomers example. So the late bloomers example refers to a classic study that's been replicated multiple times, where they've gone into elementary school settings, and in order to see whether or not teachers would become if they would sort of fall into this experiment or expectancy threat, they sort of test out the idea of experiment or expectancy. So imagine you go into you act like you're a superintendent or a high-ranking researcher about the children's educational development or whatever, and you go into a third grade classroom at the beginning of the year, and you tell the teacher, okay, I just want to let you know we did a psychological and educational assessment of all of your students, and there's a few students in your class that we've identified as quote unquote late bloomers. So, and the teacher goes, well, what do you mean by late bloomers? And you say, well, these students may, during the first, half of the year, may look like either average or even underperforming in some of their major educational areas, whether it be math, reading, whatever. But just watch. By the end of the year, by spring and into May and June, you're going to notice that these students didn't just catch up with the class. Wow, these students are actually going to overtake some of your top performing students. Now, when you set the teacher up with this, you're lying. There is no late bloomer thing. You just want to see, will that teacher be susceptible to sort of bringing in this idea of experiment or expectancy? And when this has been tested in classroom settings, sure enough, teachers will then say, okay, so these 5 students in my class have been identified as late bloomers, and then even though I've been told just to treat them like everyone else, they supposedly go about it, and sure enough, by the end of the year, those 5 students are some of the star students in the class. Now, were those 5 students really late bloomers, or was the teacher, who now is playing the role of quote unquote the researcher, were they being driven because they were fed a bunch of information and really tried to help the students, right? Did they give them extra attention? Did they find ways to ensure positive results, right? So you can imagine if all of a sudden, if I've got students that I'm going, okay, these students are going to be late bloomers. For most of you, you send me an email, you come to office hours, I give you help. But in this sort of setting, you can imagine all of a sudden, when this student, I'm checking in with that student when they're doing homework in class, go up to Susie or Sally or John or Joey and ask them, are you doing okay? Do you need a little bit extra help? So this little extra things are ways that are falsely influencing or contaminating the actual students. So with this idea of experimenter expectancy, these subtle influences or even slight protocol changes can push the treated group to make them succeed. You'll notice in the article I posted in the Oregon one, by changing some of the victim empowerment strategies, they were almost trying to make sure that they would see success for the experimental group. That's not good. That's not valid results. So things like extra attention, ensuring positive results, being extra nice, or even subjective interpretations of changes in that outcome or that dependent variable can all fall under this idea of experimenter expectancy. So how do we prevent experimenter expectancy? Well, as I said before, the term blind is going to be huge. So we had talked about, for demand characteristics, keeping the subjects. So sort of separate these out. Like the term blind just means you're unaware of which of the group assignment. So there's blind subjects, which we saw for demand characteristics as a way to stop that. If the subjects don't know if they're in the experimental group or the control group, they are blind to their situation and are more likely to behave normally. Well, since experimenter expectancy focuses on the sort of point of view of the researcher or the research staff, we do something called the blind experimenter. So if the research staff, it doesn't know which subject group they're working with at any point in time, we have the idea of known as a blind experimenter. And in a really well done experiment, if you have both blind subjects and blind experimenters, you have what is known as a double blind study. So you may have heard about this when you've heard about various studies reported in the media or newspaper or on the internet. So a double blind study is one of the best ways to prevent contamination within the experimental group. And then another way we can try to prevent experimenter expectancy is find a way to standardize the words and behaviors of the researcher or the research staff, right? So they're never able to give hints. They don't give extra information. Everything is very standard, almost recorded. And that's where, in a perfect sense, you would call it what is known as a canned experimenter. So rather than having a live person give instructions or monitor the individuals, the more that you can have things recorded, have the research subjects hear recorded tapes or watch videos giving them instructions, you're making sure everyone in the study is hearing the exact same thing. Nothing is being overemphasized for one group, underemphasized for another, and so forth. So finally, of the various categories of threats to internal validity, we have contamination in the control group. So just like if number 5 was contamination in the experimental group where we had demand characteristics and experimenter expectancy, we can also imagine that that little, sterile vacuum bubble of our experiment can also be pierced by contamination in our control group. So here is whenever we have any sort of unplanned or extraneous stimuli that are introduced to the control group. So there are two types. I think of it as either trying to do better or get pissed off and want to go home. So, and you'll see that as I kind of go through this. So the first one, like the do better for the control group, is known as compensatory contamination. Your book talks about two sort of versions of compensatory contamination called compensatory treatment or compensatory rivalry. So if the control group gets anything to compensate for the lack of getting the intervention, the drug, the independent variable, the treatment, if the control group gets, you remember, the control group is supposed to get nothing other than normal life, right? In order, if we really want to find out, does our independent variable have an impact on the outcome, only the experimental group should get anything resembling that independent variable. The control group should get nothing. But if they find a way to compensate for the lack of getting access to the independent variable, you can imagine they may perform well, or they may go in the direction that the researchers are predicting. And this will lead to an underestimate of the overall treatment effect, because if they're getting something that sort of resembles the independent variable, they may behave in a similar fashion as the experimental group. So things like compensatory treatment if they find ways and go out and get some help, if they realize, oh, I'm in the control group, I'm not getting anything, well, then I'm going to go study on my own or work on something, right? So if I'm trying to test the effectiveness of like an SAT preparation course, and I think I used this in the last lecture, if my experimental group is the only people who are supposed to be getting help in improving their SAT scores, you can imagine my control group may go, oh, wait a minute. If I'm not getting it, then I'm going to go buy some books or do some online learning of my own. They're compensating for their lack of getting any sort of help. And that's going to, once again, that's going to contaminate my overall results. Or there's also this notion of what is known as compensatory rivalry. If they're going, oh, really? Okay, you left me in the control group? Well, I'll show you, right? You can imagine how people will work harder on whatever it is. I'll be better than that experimental group just to show you that I can be as good without getting any help, right? So both of these compensatory things can lead to an underestimate of the overall effect of your independent variable. Now, on the other side is the, like I said, the pissed off. Like, I'm like, really? I'm not getting anything? Oh, screw this. I'm going to go home type thing. That is what is known as exaggerating contamination or demoralization. And so demoralization, the simplest sense by the term itself, means you participate for a study, you're hoping to get some treatment, you want to see whether or not this, this drug, this therapy, whatever it is, actually works, and you realize, oh man, I'm in the control group, and so I get nothing. Oh man, this is a waste of time. So you feel demoralized, you feel resentful, you, as I said before, you feel quote unquote pissed off, and you may just sort of give up. And you're like, well, then I'm not even gonna, and your results on the dependent variable may go even worse than they would have if you weren't sort of demoralized or upset. So this exaggerating contamination can lead to overestimates of the treatment's effect because the people in the experimental group may have shown some improvement after receiving the independent variable. But you in the control group, not only did you just sort of behave normally, you actually got worse because you're pissed off, right? So you're just like, screw this, I'm not even going to try. So these two types of ways, either going to compensate or to sort of go in the opposite way and be pissed off, are ways that we see contamination in the control group. So let's take a little closer look at each one. All right, so the compensatory contamination, as I mentioned before, is when the control group finds access to treatment that is similar to the experimental group, right? So this will decrease the perceived differences between them. So why would somebody do that? Why would they go outside of the study? Well, because if they're signed up to be part of the research study in the first place because they thought that the thing being tested was beneficial, you can imagine they're going to go and compensate for it, right? One of the things that we talk about with the article that I posted in the Broward example, you'll see that the idea of it, this is sort of at the crux of why the prosecutor's office was unhappy with it, was for perpetrators of domestic violence. It wasn't just punishing them in the normal jail or probation way, but it was also sort of mandating sort of counseling. So you can imagine if I want to get help for my drug addiction or for my criminal behavior, whatever it is, then getting access, and I realize I'm not getting that extra counseling, then I may go look for counseling on my own, right? Which is a way to compensate. Now, the reason why it was important in that Broward study was because sometimes people think, oh, counseling has to be good. Well, you got to be careful because especially in the field of criminology, we found that sometimes paying too much extra attention to a perpetrator or an offender can actually not necessarily help them, it actually can make them worse. And especially in incidences of like mandatory arrest policies or mandatory counseling and domestic violence, sometimes it can actually sort of backfire on everyone, and the individual, the perpetrator, may actually become more enraged, more upset that they have to do all this stuff. So you can imagine there's the give and take of that. So how do I control for compensatory contamination? Once again, key gold standard, blind, blind, blind. Placebos and blind. If subjects don't know that they're in the control group, they're less likely to seek out extra ways to compensate for what they're not getting. And that can be in the place of a good placebo, right? So maybe if the people in the experimental group are getting some sort of treatment, then the people in the control group should get something that sort of is fake treatment, right? I mean, it's in some ways like they have to go participate, even though it's not necessarily helping them for the issue that they're trying to measure. they don't realize that they're not receiving the actual treatment. Another way to do this is when a placebo is not available, is do your best to make sure there's no contact between the experimental group and the control group, because people talk, right? And if they go like, oh, so on Wednesday night, where did you go to treatment? And you're like, no, I didn't go. You realize that. So, and this is what makes sometimes doing like randomized experiments in like prison settings where everyone's in close area, or educational settings, school settings. Because if there's contact between the subjects and they're all in the same cell block or the same sort of series of classrooms, then they're going to talk. And so anytime that you can find ways to minimize the contact between the two groups, you're more likely to do it. Another way, which is also can be very time consuming, is to find a way to monitor the behavior of the people in the control group outside of the experiment. So this could be actually like sort of following them and checking in on them, or it can be things kind of that faithful subject of asking them to sort of report, like, have you been taking any extra supplements for this ailment? Have you been doing any other educational approaches to improve your level of education? Have you been getting any other treatment? Monitoring, asking almost like to keep a diary or monitor the behavior. And then finally, we have exaggerating contamination. Remember, this was what I called the pissed off, the resentful demoralization. This is where you realize you're in the control group and you actually say, oh, I'm upset that I'm wasting my time participating in this study, and because I'm not getting the drug, the treatment, whatever. And therefore, as I become demoralized, I'm more likely to increase the difference from the experimental group, because I may go in the exact opposite way of what everyone wanted. So how do I control for it? You'll see I'm like a broken record today. It's blind and placebo and minimizing contact. Same ways to sort of control. So within a research study, this idea of blind subject, blind experimenter, double blind, placebos, minimizing contact between the controls and the experimental group are always strong ways to sort of reduce the likelihood of a lot of these threats to internal behavior or internal validity, monitoring behavior outside of the experiment. And one of the things we often notice for the exaggerating contamination, and this is sometimes written into an informed consent document at the beginning, is we'll say some language such as, if you end up being assigned to the control group and we find that our independent variable, our drug, our intervention, show promise or show benefits, we promise you access to the same treatment at a later date, right? So at least people are going like, okay, I'm doing it for the good of science, the good of research, and even if I find out I'm in the control group, I'm not going to react in one way to compensate or to be demoralized, because I know that I will get access to that research at a later date. All right, finally, we have for this lecture is, so we've walked through the 6 main types of threats to internal validity, how they relate to experimental designs, and ways in which we can fight against them. I've mentioned it multiple times, the article that I posted up on Beachboard. I encourage you to take a look at it. And even though it's a little lengthy, read it like I said, like you're reading a newspaper article or magazine article, because it's very well written, and it hits on a lot of the great things about not only the benefits of experimental research in criminal justice settings, but also the difficulty of it, and why it gives you an idea of why most research ends up falling back into being sort of correlational or in survey-based research. So think about that. But there's also other types of validity. So going back a while back in the course, we had started off with talking about measurement construct validity. And measurement construct validity was all about how we've operationalized our variables, how well do our variables serve as accurate indicators of the underlying construct. Okay, so then we moved on to internal validity. And internal validity was all about how accurate is our claim that A causes B. And we've gone through that. Well, there's a couple other types of validity. I'm not going to go into too much length on these right now, just for the sake of time in our condensed session. But one of them is this idea of external validity. So I encourage you to take a look at pages 179 and 180 in your course textbook. They give you, they're not a lengthy discussion on it, but they give you an idea of like the connection with external validity and experimental designs. In a nutshell, external validity is all about how well do our studies results generalize to other populations, places, or time periods, right? So I'll say that one more time. External validity is all about how well will our studies results generalize, meaning apply or expect to see the same thing in other populations, places, or time periods. And this is important for external validity is important for all research, survey research, observational research, experimental research, etc. But within experimental research, we really have to pay close attention to this idea of external validity, because in order to keep sort of, as I've mentioned earlier in this, that vacuum, that sterile environment, that bubble of the experiment, one of the things we have to think about is, well, okay, once I remove my research subjects from this sort of experiment bubble, would the findings still take place in the real world, right? And so that's why in other populations, if I study and I only focus on high school students for some research, would my findings apply to college students or adults? If I focus only on men, would my studies apply to women? Right? If I'm trying to design some sort of programming, institutional programming within prisons, and I do all my research with men, is it possible that they wouldn't apply to in a female prison? Other, places. Oftentimes, especially with experimental research, they're very sort of, like, I keep using the word sterile, but I'll say it again. They're very sort of contrived, sterile environments where these things take place. Would I get the same results if I applied these in the real world where people could get away, right? One of the things we find with like addiction research, yeah, you send somebody to live at some, on a ranch out in the middle of nowhere, or at some fancy, a full-time, whatever, residential care. Yeah, you probably have a decent chance of getting them to stop drinking or stop using drugs. But will the same results apply when they're back out in the real world in a different place? Or would the results that we find, say, in California apply to people living in, Milan, Italy, right? I mean, so all these things we have to think about is trying to find out, can we apply to other times, places, or populations? And that's this notion of external validity. And it's one of the toughest things to think about. And this is why it's so important. One of the terms that I think you should be familiar with is that idea that we talked about at the very beginning of this course, that idea of replication. Can I replicate my results other places? And even though people may go like, oh, I want to study this topic, but I feel like it's already been studied. Well, try to recreate that same research study with another type of population in another place. Or if it's been quite a few years since it's been studied, see, will it still hold up in a different time period? So that's what external validity is all about. And then finally, we also have what is known as either statistical inference validity or statistical conclusion validity. Page 180 in your course textbook goes into that and its sort of connection to experimental designs. And in a nutshell, statistical inference validity is the way I typically refer to it, is I talk more about it in our CRUJU 325, our stats course. But the idea here is, as a researcher, I rarely, if ever, have access to studying an entire population. So I get a sample, right? So we talked about that with our sampling lecture a while back. I get to work with a sample. Now, I want to figure out how accurate are the findings that I get from my sample, how accurate would they be if they were applied to the population that my sample is designed to represent? So there's a little bit about this in your book. This is something we talk more about in 325 with using various inferential statistics in order to draw conclusions about the statistical inference validity of our particular data and findings, whether it be survey research or experimental research. And you can go with that. So that's what we have with experimental designs. Take care, and then I will see you with the next lecture.